Happy New Year, wetland enthusiasts, and welcome to another episode of Tidal Wetland Tuesday. As we wrapped up 2020, it was time for the wetland scientists from the Partnership of the Delaware Estuary and the Barnegat Bay Partnership to conduct a quarterly assessment. So we travel back to the monitoring wells in our coastal forest sites. As we make our way through the forest interior, we pass by seeps. Coastal forests often have low elevations where the groundwater reaches the surface, and these are known as seeps. The moist ground and the dappled sunlight make conditions ripe for tree skirt moss, club mosses, and fungi. Even this eastern box turtle seems right at home in the forest underbrush. Where we find low-lying forests adjacent to salt marshes, there is a potential for the marsh vegetation to migrate upslope with increasing sea level rise and storm surge. This process is called transgression. Sea level rise erodes and drowns salt marshes at the seaward edge, and that drives the transgression upland. At the same time, climate change has intensified the magnitude of the storms that we are experiencing. Salt spray carried by storms damages the forest canopy, and the high winds can knock these trees down. Storm surge and tidal creek flooding along coastal forests make the forest soil saltier, which has a negative impact on trees and on tree seed germination. Gradually, these stresses imposed on tree health lead to openings in the tree canopy, allowing for more sunlight to penetrate and reach the forest floor. The sunlight is beneficial to the salt marsh vegetation that is being driven upslope into the edge of the forest. This transition zone between the marsh and the forest communities is referred to as an ecotone. We have placed our monitoring wells along transects from the salt marsh through the ecotone and into the forest to record groundwater and salinity levels at each area. Our goal is to better understand transgression processes and the effects on tree health. In canopy shots taken directly above 3 of these wells, you can observe how the canopy opens up and how the forest gives way to the wetland grasses in the transition zone. Upon arriving at the site, we first assess the area and make note of any physical changes since our last inspection, and it appears we may have a downed tree, possibly from Tropical Storm Faye or Isaias that rolled through the area this summer. We then set up a temporary field office, pull our loggers out of the wells, download the data to be analyzed back at the office, and relaunch the loggers back down the wells until next time. This graph animation is from the water level data from a forest well. Depth to water in meters is on the y-axis, where ground level is y equals 0. Time, July through November of 2020, is on the x-axis. The water levels are cyclical and coincide with lunar cycling, which means that this well is tidally influenced. The spike in the water level in early August is most likely the response to Tropical Storm Isaias, which came through this location on August 4th, and which may also be responsible for that downed tree at our site. Pretty interesting, huh? Stay tuned to Tidal Wetland Tuesday posts the first Tuesday of each month to learn more about this and other projects our Wetlands group is conducting.